Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Construct k palindrome strings, Leetcode 1400. In this problem, we are given a string s and an integer k, and we should return true if we can use all the characters in s to construct k palindrome strings or false otherwise. Then in example 1, for the given string s equal to Annabelle and k equal to 2, we can actually form two palindromes using all the characters of string s. And some of the possible construction of palindromes are Anna and Elble, or Anbina and La, or Annalena and B, and so on. So we will return true in this case. But in example 2, for Leetcode and k equal to 3, it is impossible to construct three palindromes using the characters of string s. To solve this problem, let's make some important observations. First observation is we must have at least k characters in the given string. For example, if our string is a and k is equal to 2, then it would be impossible to create two different palindrome strings simply because we don't have enough characters in the given string. Now for next observation, let's look at the characteristics of palindrome a bit closely. A string is a palindrome if it reads the same forwards and backwards. For example, strings like Anna or Albele. And for a string to be palindrome, all the characters must have even frequencies to form symmetric pairs, except for at most one character which can have odd frequency. This character will be in the middle of the palindrome when the length of the palindrome is odd. For example, Anna is an even length palindrome where all characters A and N appear even number of times. And Elble is an odd length palindrome where character B appears odd number of times and the remaining characters E and L appear even number of times. So in our problem, we should iterate through string s and count the frequency of each character. Now some characters will occur an odd number of times, while others will occur an even number of times. And characters with the odd frequencies should be placed in the middle of the string to form a palindrome. Let's further elucidate this with examples. Suppose we have one character that appears odd number of times, then this character must be in the middle to form at least one palindrome string with odd length. For example, consider the string A triple B A, and here we can form at least one palindrome because B occurs odd number of times. Now suppose we have two characters that appear odd number of times. For example, consider the string AA, BC. We can see that B and C occur odd number of times. And as they appear odd number of times, they should appear in the middle of the string. So we can form at least two palindromes by keeping these odd frequency characters in the middle of the palindromic string, like ABA and C or ACA and B. So for this string, we can form at least two palindromes, and it is impossible to form fewer than two palindromes. Therefore, if we have X characters that appear an odd number of times, then we would form at least X palindromes. And for our problem, X should be less than or equal to K. Otherwise, we will exceed the number of palindromes required to form for the given string. And one last minor observation. What is the maximum number of palindromes we can form using the characters of given string? It will be equal to length of the given string, as each character can individually act as a palindrome. Therefore, number of palindromes that can be formed will be in the range x, L. Now let's see this in action. Let's take example 1 again with string as Annabelle, and we need to construct k equal to 2 palindromic strings. And here the length of the string s is 9, which is greater than k. So the next thing we will check is how many characters have odd frequency. For that, first let's build the frequency map. So here A occurs twice, N occurs twice, B occurs once, E occurs twice, and L occurs twice. And we can see that characters A, N, E, L have even frequencies, and character B is the only one which has odd frequency. So B will require at least one palindrome where it should be in the middle, and this palindrome will be odd length palindrome. And using the remaining characters, we can form an even length palindrome matching k equal to 2. So in summary, as number of characters with odd frequency is not greater than k, we should be able to form k palindromes, and hence we will return true. Now let's take example 2 where string is Leetcode and k is equal to 3. So when it comes to the length of the string, it is 8 which is greater than k, that is 3. So the next thing we will check is how many characters have odd frequency. For that, let's again build the frequency map. We can see that L occurs once, E occurs thrice, T occurs once, C occurs once, O occurs once, and D also occurs once. Here k is 3, but number of characters with odd frequencies are 6. So instead of forming 3 palindromes, we will be forming at least 6 palindromes. So we will return false in this case. Now let's jump into the code part. First we will check if k is greater than length of given string s. If it is, then it is impossible to form k palindromic strings using all characters. So we will return false. Otherwise, we will create the character frequency map to store frequency of each character in the given string. And for that, we will iterate through each character in S and update the frequency of the character in the map. If the character is not present, then we will use getOrDefault method to get initial frequency as 0, and in any case, we will increase the frequency of the character by 1. And now, let's initialize a variable odd count to count number of characters that have an odd frequency. Now we will iterate through all the frequencies or values in the map and check if frequency is odd, then we will increment odd frequency counter by 1. And in the end, we will check if number of characters with odd frequencies is less than or equal to k. If it is, then we will return true, otherwise we will return false. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the length of the string, because we iterate through a string once to count the character frequencies and then check the odd frequencies. And in terms of space complexity, it will be O of 1 for storing the character frequencies. And since we are dealing with only lowercase English letters, in the worst case, we will be storing only 26 characters in the frequency map. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.